Hello and welcome back to the session that we were dealing about normal probability curve. In the previous session, we discussed about what exactly is probability. We also discussed about few of the examples, the functions of probability curve, normal probability curve was explained to you, and it was also explained about the shape of this probability curve, the applications and the functions of normal probability curve. Well, now in this second session on normal probability curve, we will continue with the meaning of the normal probability curve and the significance as well as the properties of normal probability curve. We will also be discussing about the divergence from normality, and we will also discuss about the standard score or the Z-score. So, let us start with the significance of normal probability curve. As discussed to you in the earlier session, that the normal probability curve describes the occurrence of a large number of variables. It also helps in comparing the distribution obtained by researcher based on his or her sample data, and such a comparison with normal distribution gives the accuracy of the results obtained from the sample data. It is also used for plotting the graphs which are more towards normal shaped distribution. For example, male-female ratio, height-weight ratio, rates of birth and death, or the IQ of many people. These were somewhat related to the functions of normal probability curve. Now, let us try to understand the significance of normal probability curve. Normal probability curve is a normal distribution which is a continuous distribution, and it plays a significant role in statistical theory and inference. The normal distribution has various mathematical properties which makes it convenient to express the frequency distribution in simplest form. It is a useful method of sampling distribution. Not only that, many of the variables in behavioral sciences like weight, height, achievement, intelligence have distributions approximately like normal curve. Normal distribution is a necessary component for many inferential statistics like Z-test, T-test and F-test. So, there are many more applications, many more functions of normal probability curve. Now, let us try to see what are the other importance and reference of normal probability curve. As mentioned to you earlier also, that it is a distribution of a random continuous random variable. It is also known as Gaussian distribution. The normal distribution curve is also known as Gaussian distribution after the German mathematician Carl Gauss, who first tried to describe the normal distribution. A normal distribution is determined by two parameters, the mean and the variance. A normal distribution with a mean of 0 and a standard deviation of 1 is called standard normal distribution. I repeat, a normal distribution with a mean of 0 and a standard deviation of 1 is called standard normal distribution. This normal distribution is important to predict the probability distribution in statistics. It is one of the most powerful statistical tests used by psychologists to determine for the normal distribution of the data. If the data does not resemble a bell curve, then the researchers may have to use the type of statistical tests which are called as non-parametric statistics. So, parametric statistics can be used only if for the data which is in a normal distribution. Now, let us talk about the properties of normal probability curve. As you can see in the slide, the normal probability curve is symmetrical in nature, that is it follows a particular symmetry, that is it is in a inverted U shape, broader at the ends and at a high on a peak in the middle. Second property of normal probability curve is that it is unimodal. Now, what does this mean? Unimodal refers to that the mean, median and mode fall at the same point. So, for the in the normal probability curve, the mean, median and mode of a data fall at the same point. Next property of normal probability curve is that it displays a point of influx. The area of the normal probability curve within both the points of influx has a fixed total percentage. Influx refers to the larger number of distribution of a particular data at a particular point. So, the area of normal probability curve within both the points of influx has a fixed total percentage. The total area of normal probability curve has 100% probability. Okay. So, this refers to the properties of the normal probability curve. Now, we all discussed about how normal probability curve is used in statistics, because if a distribution of a particular data is in NPC, is in form of normal distribution, then there can be parametric statistics that can be used for statistical analysis of the present data. Many a times the data do not fall under the normal probability curve, and this is known as divergence from normality. So, now let us try to understand what is the meaning of divergence from normality. The term that has been coined to this or given to this particular divergence is known as skewness. What exactly is skewness? It is a particular distribution when mean and median do not fall at the same point as it is in normal distribution. So, we discussed about one of the probability of normal probability curve, that it is unimodal in nature. The mean, median and mode of that particular data falls at the same point. But few of the data which follow skewness, in them, among them, the mean, median and mode, mean and median do not fall at same point. As they fall in normal distribution, and the curve either is tilted towards left or right side, which indicates higher scores on the left or the right side of the axis. You can also see it in the diagram as mentioned. The skewness or the shape of the data of the curve represents how a particular data is falling more on right side or more on left side, how the scores are falling or more towards on left or towards on right in the x-axis. And basically there are two types of skewness which are divided on these two categories, which are divided on basis of the side in which this curve tilts, that is either on the left side or on the right side. So, let us try to understand what exactly are the two types of skewness which is described on basis of the side on which the curve falls. Now, the two types of skewness are positive skewness and negative skewness. So, let us try to understand what exactly is positive skewness. Positive skewness occurs if the scores are piled up to the left side of the curve and slowly taper off to the right on the x-axis. As you can see in the diagram, where mean, median and mode are not falling at the same point, and the scores are piled more on the left side of the curve and they are slowly tapering off on to the right on the axis. So, this is known as positive skewness. Now, negative skewness is opposite of the positive skewness, where the scores are piled more on the right side of the curve and they slowly taper on the left side of the x-axis. Now let us come to know about another divergence from normality, which is known as kurtosis. What exactly is kurtosis? It is different from skewness, as in this higher number of scores concentrate in the midpoint and lesser number of scores there are lesser number of scores for above from the midpoint. So as you can see that is, it is different from skewness on basis of the distribution of normal probability curve. That is why it is known as kurtosis. Kurtosis are basically of three types: leptokurtic, mesokurtic and platykurtic. So let us talk about leptokurtic first. Leptokurtic is a type of kurtosis which occurs when the scores are higher towards the midpoint. If there are more scores towards the midpoint, then it's a leptokurtic curve, and this gives a peak at the center to the curve. Though the mean, median and mode fall at the same point, the other properties of normal distribution do not hold good. Now why is it being said so? Because over here the scores are higher towards the midpoint, and that is why there is a more chance that the mean, median and mode fall at the same point, but the other properties, that is, it should be a symmetrical bell shape and other properties, are not followed in leptokurtosis, and that is why it is not a normal distribution curve. And the curve, though is symmetrical, a leptokurtosis curve has a higher peak at the center when compared to the normal distribution. That is, even if it appears to be symmetrical, it is not symmetrical. It has the property of having mean, median and mode at the same point, but it does not follow the other properties of normal distribution. So this is something about leptokurtic. Now let us see what exactly is mesokurtic. Mesokurtic is a distribution which is somewhat similar to that of normal curve, but it does not have a peak as it is in leptokurtosis, though the number of scores are higher at the center as compared to normal distribution. That it appears to be a normal distribution, but the number of scores in mesokurtosis is more in the midpoint. What exactly is platykurtosis? It is a third type of kurtosis in which there are lesser scores comparatively at the center, which gives a flat look to the curve. So the curve is more of a flat shape. As you can see, all the three types of kurtosis in this particular diagram, where the three have been represented by as leptokurtosis and mesokurtosis as well as platykurtosis. Now, if we talk about the divergence from normality, we talked about skewness, we talked about kurtosis. We should now try to understand if there is a data which might be under normal distribution, then what can be the cause of divergence from normality? What are the causes of the divergence from normality curve? Now, it depends upon the nature and the selection of sample. Many a times there is a divergence from the normal distribution curve only on basis of, which may be on basis of nature and selection of sample. If, say for example, there has been a biased sample selection, that is, it might be on basis of some particular biasness or some kind of a selection which is more on basis of certain criteria, which is more towards the researchers' biasness or favoritism kind of a biasness. Or if the sample is too small, if there is a small sample, then also there is a chance of the divergence from normality. The second cause of divergence from normality is inappropriate measurement tools. The measurement tools that have been used, if they are not appropriate, then also there is a chance of causes of divergence. The third cause of divergence can be nature of the variable that has been included in the research. It can be on basis of the variable that has been selected, there can be any divergence in the distribution apart from the normal distribution of curve. Now, since we have discussed about the functions, the significance of normal distribution curve, we also talked about normal distribution, we talked about divergence from normality, we talked about the two types of divergence from normality, one was skewness, the other was kurtosis. We also talked about the causes of divergence. We now move to the concept of standard score. Standard score is also known as Z-score. Now, what exactly is standard score or a Z-score? Before trying to explain you what exactly is that, let us try to understand an example. Many a times you might have discussed, say if we take an example of any particular fruit, if we take example of two fruits, you might have discussed many a times, or you might have discussed about the strength or intensity of sweetness of any fruit. Say you might have discussed, you might have ever thought whether peach is more sweeter than grapes, or grapes are more sweeter than peach. And many a times there are polls and surveys which are usually done, say to take public opinion on certain aspects, say political aspects, say current environmental climate crisis or some things. Many a times there are public opinions, polls, surveys that are done to understand the significant difference, to understand, to compare say two things on basis of particular background, on basis of one similarity. Now, this, when we talk about in terms of statistics, this is used to generate the standard scores. So, what exactly is standard scores or the Z-score? A Z-score is a raw score which is expressed in terms of its position, that is on basis of the relative occurrence, relative mean in position to what is its position in terms of mean, in terms of standard deviation. A negative Z-score means that the raw score is below the mean, and a positive Z-score means that the raw score is above the mean. So, what exactly is a Z-score? It is a transformed score that designates how many standard deviation units the corresponding raw score is above or below the mean. As I said to you, if the particular score, raw score, is above the mean, then that is a positive Z-score, and if it is below the mean, then that is a negative Z-score. And the Z-score communicates the score's distance from the mean in terms of how many standard deviations away it is. Okay. So, it represents the deviation from the actual mean, which may be above or below the mean score. A raw score, say X, or sample value cannot give you any information of its position within a distribution. So, in order to understand the position of these raw scores, the raw scores are transformed into Z scores to understand the location of the original scores in the distribution. The Z scores are also used to standardize the Z scores are also used to standardize an entire distribution. Now, let us take an example. Say for example, your result shows that height of a particular person. Your result over here refers to a researcher's result or findings. If the researcher's result shows that the height of a particular person is 6.5 feet, such findings can only be meaningful if you compare it to average person's height of a particular country, of a particular place, locality, looking at a vast table of data. In such a case, the Z-score can tell you where the height of that particular person is in comparison to the average population's mean height. So we discussed about the value of z-score, the role of z-score, and how the raw scores are interpreted on basis of z-scores. Let us discuss about the basic properties of z-score. The mean of z-scores is always 0. Secondly, it is important to note that the standard deviation of z-scores is always 1. The graph of the z-score distribution always has same shape as the original distribution of sample values. Next property is that the z-scores above the value of 0 represent sample values above mean, while z-scores below the value of 0 represent sample values below the mean. The shape of distribution of z-score will be similar or identical to the original distribution of the raw measurement. Thus, if the original distribution is normal, then the distribution of z-score will also be normal. The z-score tells you about how many standard deviations away from the mean the raw score actually is. The z-scores are useful for comparing scores across two different variables or across different variables. So, it is also used for comparing various scores. In statistics, the mean grade or the z-score is the distance which on basis of which we can summarize that the standard deviation in statistics or the standard deviation of a particular score is how far from the actual mean. So, this is property of z-score. The z-score is computed with help of a particular formula where z is equal to if x minus m by st, which refers to the mean, the standard deviation and the score, the raw score. X is the raw score, mean is the m and the standard deviation is st. So, z is equal to x minus m by upon sd. So, this is the formula with the help of which z-score can be, a simple data of z-score can be computed. Now, let us discuss about the uses of z-score. Z-score helps in identifying the position of observation in a population distribution. It is used for standardizing the raw data. It is used for interpreting the raw scores, and it also is used to see the deviation of the scores. It helps in comparing scores that are different from normal distributions. So, this is something related to normal, related to the z-score or the standard score, which is very much used to represent, to interpret data in a particular distribution, which and it is also used for comparing data. So, we discussed about, this is all that we discussed about in the present session. In the previous session, which was the first session on normal probability curve, we discussed about the meaning, the reference of probability, the formula of probability ratio and the relevance of probability prediction. We also discussed about normal probability curve. We discussed about how this distribution is useful, what are the functions of normal probability curve, and in the present session, we discussed about the significance of normal probability curve. We also discussed about the divergence from normality. We discussed about the relevance or we discussed about how what is the application of z-score or standard score in the normal distribution, and how is z-score used in statistical analysis, what are the functions of z-score and what are the applications of z-score. So, by now it is expected that the concept on normal probability curve might have been clearer to you, and this particular class, this particular session might have helped you to get a clarity on the picture of normal probability curve. So, thank you so much for this session. Thank you.